In this video, we're going to be looking at atomic number and mass number and how we can use those numbers to get information about the atom and the element that we are looking at. So first is the atomic number. The atomic number is very specific to the element that it represents. So when you change the atomic number, you actually are changing the element, and vice versa. You change the element, the atomic number changes as well. When you're looking at the periodic table, that number is going to be your whole number, and it's usually at the top of the box for that element. The other number is the average atomic mass, which we'll be looking at in a different video. So helium, every atom of helium will always have an atomic number of 2. Now, if we were to change that number to a 3, we would no longer have helium, we would have our element lithium. If we are not given information from the periodic table to identify the element and we are given a model of the atom instead, we can still use that to identify the element. So the atomic number, when you're looking at a model of the atom, is actually the number of protons. So from the periodic table, we know that helium has an atomic number of 2, and on this model of the atom, we have 2 protons. So those numbers are always going to be the same. If you were to change the number of protons, you would also be changing the element. The second thing we're going to look at is mass number. If you remember from one of our previous videos, electrons don't have any mass. So when we talk about finding mass, we are strictly looking at the nucleus of the atom. So given a model, you can count up the number of particles in the nucleus to find the mass. Or you can take the number of protons, which we know from this picture is 2, and take the number of neutrons, which we can count, the green ones are also 2. And that's going to give us a total of 4. So this atom has a mass of 4. Our first example problem is identify the atomic number, mass number, and element from the image below. I want you to pause the video, try this yourself, and then when you are ready, unpause it and check your answers. Okay, if you are unpausing, that means you have tried this yourself and you are ready to review the answers to example problem number 1. So first up is atomic number. We know atomic number is a number of protons. And from this image, there are 1, 2, 3, 4 protons, the positive ones. So we're going to have an atomic number of 4. Our mass number is protons plus neutrons. We have 4 protons already. And if we count the neutrons, 1, 2, 3, 4, 5, 4 plus 5 equals 9. So you can either do it that way where I added the protons and neutrons together, or because we have a picture, you can just add up the whole center. And then the element, which is identified by the atomic number, the element that has the atomic number 4 on your periodic table is going to be beryllium, which has the symbol Be. Our second problem we are going to go over is an atom has 5 protons and a mass of 11. How many neutrons are there in the atom? So you're going to have to rearrange our equation to figure out the number of neutrons. I want you to pause, try it yourself, make sure you show your work, and when you're done, unpause and check your answers. If you are unpausing, you are reviewing your work and your answer with mine. So to get neutrons by itself, we have to get rid of protons from this side of the equation. So we're going to subtract protons on both sides, and that gives us mass minus protons equals neutrons. So if we have a mass of 11 and we have 5 protons, 11 minus 5 is going to give us our number of neutrons, and that is going to be 6. If you just wrote the number and you didn't write out the work to it, please make sure you go back and do that. That'll help you remember how to solve for neutrons. So, atomic number is the same as your number of protons, and both of these are used to identify your element. Looking at the periodic table, it's going to be your whole number, and if you're looking at the model of the atom, it's going to be your number of protons. The other number that we looked at is mass number. So if you remember, only the particles in the nucleus have mass, electrons don't. So you're either going to count all of those up, or you're going to follow the equation of protons plus neutrons to get your mass number. And then if you're solving for neutrons, it's going to be mass minus protons. So make sure all your guided notes are complete, and then you can go on to the next activity.